Today's webinar is on changing behavior to save energy at University of New Mexico. This is a near and dear topic to us because as a software company, we like to hear stories about how clients are implementing a lot of energy saving initiatives in their organization and then using software to monitor and track avoided usage and avoided savings that they've calculated due to their energy management projects. So it's great to hear client stories about how they're making use of our software and hear what they're doing. So today's webinar is going to be presented by Matthew Cherrin at the University of New Mexico about how they've implemented behavior programs around the campus. So with that, let me pass it over to Matthew, and the floor is yours.
All right, thank you. Like John was saying, my name is Matthew Cherrin, and I'm the vice president of a company called Lobo Energy. And I graduated from the University of New Mexico back in 2009. And right out of school, I was hired as an energy specialist for this behavior modification program that the university wanted to implement. And since then, I've been here almost 9 years, and I'm now a vice president, so it's been a great job for me. And just to give you a little backstory about Lobo Energy and our relationship with the University of New Mexico, the university had an issue almost 20 years ago, well before I ever started. And the rates were increasing from our local utility vendors. The equipment was aging in buildings, and the demand on campus was rising. So the university decided to create Lobo Energy under the University Research Park and Economic Development Act to help solve some of these issues. So Lobo Energy came in and helped figure out putting new efficient equipment in our district utility system. We did some lighting projects, and most recently, while I was hired, we started a energy conservation program based off behavior. So the former president named David Schmid Lee, he just started at the university coming from Oklahoma State, and he had already implemented a similar behavior program there. So he knew that it could work here, but he needed to see if there was a need for it. So he drove around at night when nobody was here to see if there were lights being left on, if buildings were still keeping temperature during the night when nobody was there, and see if there really was an opportunity to change the behavior and the culture on campus. And when he did drive around, he did see that there was tons of opportunity. So we started this program back in 2008 to really bring a dedicated focus and communication to trying to get people more aware of all the wasteful behavior that was going on. And the way that we approached that was that we created a team of 5 energy conservation specialists, and all of us were assigned a specific section of the campus and a number of buildings that we had to go through and try to look for energy conservation opportunities. Now, just to give everybody an idea, UNM has over 12 million usable square feet, and we have 6 branch campuses, along with our main campus and North Campus and South Campus. And in our main campus area, we have 5 maintenance areas, including the hospital. And so all of us were kind of luckily assigned a specific area. If there was one person for area 1 buildings, one person for area 2, and then we so on, but we kind of mix and matched some people crossing over to different areas, but trying to figure out, who would be responsible for these sections of the buildings. So our goal again, was to constantly search for nickels and dimes, whether it was a problem with the lights staying on when nobody there, or computers or monitors, or finding issues within the HVAC equipment. We are always looking for those zero to low cost opportunities that we could hopefully turn around without anybody really having to put a lot of financial backing into it. So we would do audits of the HVAC and lighting systems, and we're always looking for those failures and successes. So if we tried to implement everybody to turn off the lights, then we'd go back through the next week to see if that was actually something that was achieved or not. Same with if we end up saving a bunch of energy or reduce energy consumption, we want to go and make sure that we know the reason why and really take note of those successes or those failures. And we're going to be the ones who are continuously monitoring the people and the systems to make sure that those always stay the way they are, working as efficiently as possible. So just to give everybody kind of a backstory, the university has avoided around 22% of our total energy usage since 2008. And that's millions and millions of dollars that we didn't have to pay the local utility companies compared to now. And our program is really just a small piece of that. Of course, the engineers are putting in, high efficiency equipment, and the people in the buildings are the ones who are actually helping us save the energy. But we're just a small piece. Our energy conservation program really is something that happens throughout the entire UNM community. So we're focusing on kind of making sure all those silos are communicating with each other and are aware of all the wasteful behavior. So we're the ones in the building who are now going to communicate with personnel and make sure that they're aware of all the wasteful habits or the opportunities that are available, right? We're bringing dedicated focus to something that people can really get together on and say, man, we've really achieved a really good goal here. So we're communicating with people and we're learning who is responsible for the buildings between the people in there and our physical plant department. Our physical plant department is obviously key into any energy conservation opportunity because they're the ones that are maybe putting in that high efficiency equipment or fixing an issue and really helping us address problems quicker so that they don't become long-term issues and cost us more money and energy. So we're trying to change the culture when we first started from somebody just saying, oh, you know what, I'm just going to leave my computer on all night or leaving their lights on, to just kind of being aware, right? You want to be aware of these wasteful habits. And that's just not the person in the building. That's also maybe the HVAC mechanic who is changed a schedule to 24 hours a day so he could fix an issue, but forgot to change it back to a 6 a.m. to 10 p.m. schedule so that you could save some energy in the middle of the night when nobody's there. So it is about turning off lights and computers, but it's also about making sure that you're constantly looking at these HVAC and lighting systems to see if you are running them the way that they were designed to be run. And that's kind of our goal. We're doing a continuous commissioning process as well as energy audits. So we're also doing all the measurement and verification. And every organization really has a data that they can pull and they can monitor what's going on, but unless somebody's constantly looking at that data, you're not sure exactly what the data is telling you. You really need the data to tell a story, and that's, I think, where we kind of fit in with the dedicated focus, is we've become the storytellers of our energy conservation program, because we look at the data monthly to make sure that all levels are working compared to what they were doing last year and compared to our baseline year. If you don't have somebody doing that, then issues might arise that are missed. Like if you're at home and you get a water bill that was $200 more than what you were using last year, you're going to say, okay, well, what changed, right? And that's where we're here, is kind of to become the storyteller and tell you how that did change and where our energy conservation numbers are at currently, so that everybody really understands how this program is working. So the way that we started with our program was that we needed to collect data. Without data, there's no way of figuring out how your program is actually benefiting the university. So we had to figure out, how are we going to collect data? And we have two different real sources that we pull from. The University of New Mexico has a district energy system where we can create almost 13 megawatts of power through cogeneration, and we produce chill water, electricity, and steam. We make electricity with natural gas, and then from the wasted heat, we capture that and make steam, and then we have a chiller plant. So we have a district energy system that had meters that we were pulling from. And then we have our local utility companies for all the off-site buildings around in Albuquerque. And then we have the branch campuses too, that we work with their local utility companies to gather that data. And then we needed a place to store that data. And that's where Energy Cap has been such a great tool for the University of New Mexico, because we might have already had interval data, because we have chill water, steam, electricity measured throughout main campus, but we didn't have a way of just looking at it in a very easy monthly basis. So we are taking our local utility company data and our interval data, and we are putting it into Energy Cap. Now, if you don't have Energy Cap, Excel is a great tool. Just, you have to have some type of way of storing it, but Energy Cap has just made so many processes a lot faster and easier for us. And then you have to, of course, have someone who's always looking at the data. So like I said, we have an interval data system where we can actually pull data by the hour to help figure out what are our consumption patterns on a daily, monthly, and yearly basis. So right here in our little graphic, we only have to put a building right here. So in this case, it was the Math and Science Learning Center. We put the dates, and then we can calculate what that building was using within that time frame. So it's made our job a lot easier. And then we have the local utilities for our branch campuses and offsite buildings. And we set up profiles online so that we could pull data in a quick manner, so that we didn't have to call them or wait for the bill to come in. New Mexico Gas Company and PNM, they all have ways of creating profiles so that you can just download the data immediately. So these are our local utility providers, and we have figured out some type of way to gather that data and get it into ECAP. So we take Energy Cap, and it's allowed us from that data to create import processes. So we take our district energy system data through interval data, and then we download it. And then Energy Cap helped us create a import sheet that we basically transport data from one page to the other, and then we upload it, and it's done. And it's a very easy process. We also use the bill capture service for our vendors. We didn't used to do this. We used to manually enter them by hand. and that would take a long time, even though it was still worth it. But the bill capture service has basically reduced a 3-hour, 4-hour project of just getting the data in the ECAP to, within 30 minutes you're done. After you send them the bills, you scan them, you send them to Energy Cap, they upload them for you, and it's in ECAP. And the best part about bill capture is it kind of taken away that user error, that where you might be typing in a bill and you might have hit an 8 instead of a 7, and collecting all the other parts of the bill that we really weren't focused on. For instance, we only would put usage and cost into ECAP, and these are kind of putting all the other metrics that come with it too. So the bill capture service has been great for us, but we do still have some bills that are being manually entered into the software. And those are for kind of the other vendors that really we don't need bill capture for, because it's only a few different bills. But it doesn't take that long either. But and then we use the web version of Energy Cap. It used to be just a desktop version, but ever since it went to internet-based, we've allowed other people around the university to actually get into ECAP and look at their data for their internal purposes. So that's kind of how this data is being manipulated to get into the system and who's using it. And these are all the things that we are using Energy Cap for. I specifically am working on the measurement and verification. So I look at account and meter tracking our bill entry and auditing, and definitely the cost avoidance and use avoidance. But we have other engineers and other departments around the university that are using budgets, that are using energy use intensity, use versus weather. And we're going to really start with the new version, kind of focusing on getting our dashboards in place. But these are the things that the university right now is using Energy Cap for. So like I said, after you get the data into ECAP, there has to be one person assigned to look at the monthly consumption and keep track of the overall numbers of the program. If you don't have the numbers and you don't have that person focusing on it, then you can't really verify what you're doing in the building is actually making a difference. So for the first few months that I first started, I was assigned hospital buildings, but we actually didn't have any data in Energy Cap for those buildings. So I would always be sitting there scratching my head, wondering if some of the energy conservation opportunities that we were implementing actually were affecting the overall numbers. And without the overall numbers, you're also not able to make other people buy into your program as well, right? By showing them what your cost avoidance is and what your usage avoidance is. And you always have to have a baseline that you're comparing back to. Now, your baseline over a 10-year period is that building is gonna change dramatically. And so you set the baseline and decide what are you always gonna compare back to make sure that you're not going back to the same negative patterns that were making your energy usage spike, right? So for us at the University of New Mexico, the baseline is May 2007 to May 2008. So every month and every year we're comparing back to that timeline. And if it's something is over that amount, then we're going to go and we're going to check out that building and see what changed. And if something dramatically changed to reduce the energy consumption, we're also going to check it out to make sure that every amount of, well, we use MMBTUs for universal units, but it could be kWh, it could be 10 hours. All units are basically accounted for so that you can easily calculate your cost and usage avoidance and really tell the story of how the university or how your organization is avoiding energy. So we make reports for, like I said, the occupants and the administration. because your HVAC tech might not be willing to help you if he doesn't see that it actually does make a difference. Or your building manager might not let you set back the temperatures at night if it's not actually saving or reducing energy in the building. So you really have to figure out who you're talking to, who your audience is, and show them the reports that helps them figure out their job. Some people might be interested in expenses and the financial, and then you'll have the other person who's really interested in the environment and reducing carbon footprint. And so each type of audience has a different report that tailors to them. And that's kind of how Energy Cap has helped us, is that we have a usage avoidance report that we give to the people in the buildings, but we can also give a cost avoidance report to the financial administration so they can really see the difference on both sides of our program. So you have to find the audience, and you have to show them how what they're doing is actually helping the program. And so you need to figure out who your champions are in and outside the building. For us, building managers are huge, and department managers. These are the people who are letting us do our schedules, who are communicating with us if there are issues with comfort or with systems in general, like lighting systems. And these are the people who you are always going to be talking to, because their job, the personnel doesn't really have a big changeover. Now, students and teachers, they're huge too. They change over a little bit more, so you always have to be kind of reintroducing the program and to these types of people. And then, of course, the custodians and security, they're also like the building managers and department managers. They can be really useful in making sure that things are being set back at night, or lights are being turned off, or that we can actually schedule around some of these things to make sure that they're comfortable when they're going through the building, and that everybody is really involved in this community-wide effort. And then you have your team outside the buildings, your champions that you need on your side to get anything done. And these are your physical plant people, the maintenance team, the engineers, the scheduling people who are sending you what classrooms are actually being available when nobody's there. We have an energy controls department that, for automated logic and Delta, help us do all the schedules or help us find issues within equipment and really address them before they become bigger issues. Deans and department heads, these are all your champions outside of the building that you need to be able to get your program going. And then, like I said, you have to know who you're talking to. Is this environment, financial, comfort? Is this a professional personality? Is this something that really you need to figure out how they vary between each type of person? And then some of these issues that arise, or some of these conservation opportunities, you don't really want to force the issue down these people's throat, because these are your champions and they're going to help you do it. But in the end, the university is here to help provide a culture of learning and getting their job, the people who work for the university getting their job done. And we're not trying to get in the way of their job. When we first started, people thought that we were going to go through the buildings and turn off the lights on them in the middle of class or in the middle of work, and that we were going to freeze everybody out so that we could save energy. And that's really not what we're trying to do. Because once you do that, and let's say you do that to the athletic department, you're going to have a coach calling a vice president, and he's going to be complaining. And then all of a sudden your program is stopped and distracted because you can't do some of the things you need to. So you really have to work with these people, suggest trial runs and making recommendations, so that they know that you're not here to change anything without their permission, And you're here really to work with them to say, hey, if we're not doing this, can we save some energy? And then, like I said, you have to prove that worth with ideas and data. You always have to give feedback. And that'll kind of go into our flow chart that I'll show you here in a little bit. For the energy conservation specialist, it was really important for us to learn the building systems. So that when we were talking about issues with our physical plant department, we could not sound like we didn't know what we were talking about. So we always say when you first start, you have to figure out where the meters are located. What type of systems does the building use to heat and cool? Is it a rooftop unit? Is it a dual duct system, single duct, multi-zone unit? Where are the mechanical rooms located? You know, a lot of buildings have a mechanical room on each floor sometimes, or one giant one in the basement. And so you need to be able to describe where that problem is if you see one. You know, sub panels, where are the valves located going in for us from the district energy system, the lines going into the building or coming out. Does the building have its own heating system too? Is it a boiler, or does it have a steam system? Constant air volume or variable air volume systems. You need to make sure that you can talk about these parts of the HVAC equipment clearly, so that, like I said, you have a little bit of credibility. And then you want to know what kind of lights you have, what kind of control systems, does it have daylight harvesting and security lights? All these things really help you build credentials for talking and speaking with your physical plant department. And then this is kind of, doesn't seem as important, but you really do want to know what kind of space type and building that you're working with, because each building is going to have a different type of function. You know, obviously, if it's a residential hall, you're not going to be able to do temperature setbacks, right? Because there are people living there 24 hours a day. If it's a research area, you're probably not going to be able to set back temperatures if there's labs and research going on there, because you can't get in the way of those experiments. Is it an office building? Because then you can actually do probably a normal daily 40-hour-a-week schedule to work around. You know, when everybody is there from 8 to 5, you can set that temperature to be unoccupied when nobody is there. So you really have to know what kind of space you're working with and the building type. So after you kind of get this really good idea of data and what the systems are, who you need to talk to, you can really start to begin our program. And so it would take us months to kind of get all these things in line. But after you do that and you have good documentation, then it becomes a very monotonous program where you have to wake up and do the same thing over and over a day again. So it's kind of like, you know, we like to say it's kind of like a donut shop, right? Every morning you have to wake up, get there in the morning and start doing what you need to do to get your donuts ready for when the building opens, right? Or for when your donut shop opens, so that when people come in, you can just hand them the donuts. And for us, it's the same thing. Every week we have to get ready and do kind of the same audits and the same commissioning. It's a very rinse, lather, and repeat process so that we can find some of these issues before they get bigger. And so we have to make sure that if we keep doing these things over and over again, the occupants and physical plant department know that our program's here to stay and it's not going away. You know, I think a lot of people thought that this is only going to be a couple year thing and then we'd be fine. But after seeing the results and after seeing us going through the buildings over and over again, I think people really realized that we were here to stay. And every single year, we got a little bit more positive feedback and more people on our side to try to help us do what we're doing. And so once they figured out we were going to never stop looking for those failures and successes, the program really took off. So we're kind of the eyes and ears of the program, right? We're not the ones fixing the issues. We're not the ones putting in the new HVAC equipment and higher efficiency equipment, but we're the ones who are always kind of looking for that stuff and making sure that the engineers and the people in the building and the maintenance department are aware of all the problems that might be there or all the successes, right? We're bringing that dedicated focus to consistently look at the HVAC issues. Because heating and cooling equipment, I don't care where you are, at one point it's going to fail in some way, right? And you're going to be using more energy than you should be. So we're just here to relay those problems so that they know about it and then they can fix those in a timely manner. You know, just to give you an idea of an issue that the university had is we had a steam leak by our law school for years. And because that issue wasn't fixed in a timely manner, it probably ended up costing us a lot more money not to fix it than it was to get it done immediately, right? And there's always going to be an issue with trying to fix that problem as fast as you can because you have budgets that you're trying to work within and you were already planning on spending that money in a different way. But some of these issues, if they're not fixed in a timely manner, or if they don't know about it, they end up making your budget become less and less because you're paying more to the utility company or for us to our district energy system or plant. So we are the ones who are kind of communicating to get those issues fixed in a much quicker manner. And then we're always following up. We're always bugging people to just kind of be aware that this is still not fixed. You know, we just put in a new control system in one of our buildings, and we haven't yet put a new schedule on because it's a new system and we're trying to work out some of the kinks and there's some issues that still need to be figured out. But the longer that it's not being a schedule's not being implemented, then it's more usage and more cost that is affecting the university. So we're obviously if it needs to go in a certain order, we understand, but we're always still going to remind people just so that they're aware that this is causing energy to spike and expenses to go up. So this is kind of our energy conservation process flow chart. Excuse me. And like I said, this always starts with dedicated focus. You have to have somebody looking at these things. And for us, the four main parts of it are the utility management, getting the data in there, doing audits and the continuous commissioning, energy conservation opportunities, and communication. And you can go down through your energy cap and your bills, and you can look for those outliers that are saying, hey, where are we spiking? Where are we reducing? Where is there inefficient consumption patterns? And that can lead to an audit, that can lead to communication, that can lead to an opportunity. But in the end, all these kind of end at energy conservation. Because if you then look at the audit and you look for problems or you find that opportunity, you're communicating that and issues are being fixed and opportunities are being realized and you're actually saving energy now or reducing energy consumption. So this is kind of our process flow chart that we use here at the university to capture those. So just to kind of go over those areas is, like I said, we're always searching for outliers. I meet with my team on a monthly basis and we go through some of the reports that we've created to figure out what's going on. And I'll show you those reports that we use, but we'll sit there and we'll say this building used 20% more energy, what changed? And then we'll do some research and we'll find that a schedule got changed and nobody put it back. Or that we had a broken valve on the chill water and it's the middle of winter and we're using a lot of chill water for no reason. So we're looking for those spikes and reductions. We're doing on-site and online audits. So We're very fortunate at the University of New Mexico to have a lot of DDC controls. We use automated logic and we use Delta control systems. And we can go into our office and see if everything is working accordingly. And then we also do unoccupied audits, and we go through the buildings and the mechanical rooms to see that if nobody's here, how's the building functioning during unoccupied hours? And then we're communicating that to key building personnel, and we're discussing those numbers and those issues with the maintenance team. And so we look at the data from a campus level to a building level to a meter level. And this kind of gives us a focus of where we should prioritize some of our audits and some of our focus for the upcoming week. So here's one of the reports that we use on a monthly basis. So this will be for a specific person. So I have an energy conservation specialist assigned to every area like I spoke of, and we would pull up their buildings in one big collective universal unit of MMBTUs. And the higher the number here, actually, the better. We're looking for, this is an avoided use by performance year. So we're just looking at the usage and trying to see, are we doing better compared to our baseline year back in 2008, or are we doing worse? And we're doing it on a month-to-month basis, and we're combining all utilities together. And then we take the same report and we break it down by commodity. So then we also have this for all the buildings, but just electricity. And then we have one for this, but it's just chill water. And that way, if we see a reduction, like you can kind of see in February here, we can go back and see, well, which commodity was it? Was it electricity? Was it steam? And that gives us a focus on which buildings to kind of look at. Then we go over the building data, like I said. So this is one of our energy conservation specialist report. And you can see that that gives you a use avoidance percentage compared back to our actual usage back in our baseline year. So we take the current conditions, our baseline adjusted to current conditions, and then our actual usage, and we come up with a number. And so Dane Smith, I know, is a building that's usually in the 20% range. What happened this month? Or, man, Laguna Hall saved 34%. You know, how did we achieve that? So we're always looking for those ways to figure out what's going on in the buildings, good or bad. And then we go down to the meter level. So after you figure out which building and which commodity is not doing well, you can go right to that meter and see exactly what's happening. So this is a normalized report. So we're taking data and we're comparing it back to our baseline year during certain weather or heating degree days, cooling degree days, square footage, definitely wet weather patterns, and making sure that we're at least trying to compare it as close as we can, apples to apples. So you can see in February, where you have this 131, if the number is red, it means it's higher than our previous year by more than 10%. And if the space is yellow, then it's higher than our baseline year by more than 10%. And so this gives us really quick ways of identifying issues or identifying successes on a monthly basis. So in this case for Dane Smith, like I said, it's usually 20%, but we used a lot more steam. We would then go and check the heating system to make sure that it's running the way that it's designed to. So then after we do the data, we do our ASHRAE level 1 and 2 energy audits. These are simple audits. We're always looking for 0 to low cost initiatives for our both energy level 1 and 2 audits. The level 1 is that you're basically doing walkthroughs, you're doing brief interviews with the people, you're looking at the usage. And then level 2s are, like I said, those low cost, 0 to low cost initiatives where you're taking what you learned in level 1 and taking it kind of to the next level. So this could be with building envelope, lighting, HVAC, occupancy behavior, but you're going back through and kind of trying to identify the larger issues. And then these findings for your audits should really be able to be implemented in a timely manner with 0 to low financial backing. When you're doing a level 3 energy audit, that's kind of when you're saying, all right, let's do a complete replacement of lights, or let's put in a whole new HVAC system. These are very 0 to low cost initiatives, because you're going to let the engineers do what they need to do for the lighting and the upgrades, and let them focus on that while you're focusing on the little things. So then you're going through, like I said, you're doing your online audit, your physical audit, and these are the things that you're kind of looking for. So you pull up your air handler unit, you're looking for schedules, you're looking for set points. You want to make sure that the delta T is right. You know, if you have a very low delta T, there might be a problem, or high. You want to make sure that the mixed air temperature is good. The outside air isn't bringing in too hot of air that's making you cool more, or open your valve more to cool quicker. Valve positions, discharge air, these are all things that you need to weekly look at so that you can make sure that your building is working like it was designed to. And then during unoccupied audits, our team goes through when nobody's there. This could be at 5 a.m. or after at 10 p.m. and you're making notes about what you're seeing in the building and what type of opportunities there are. And then you're communicating your findings to the correct personnel so that they know that, okay, that's because this happened, let me change that real quick. And then you have to make sure that after you do communicate that problem, that the issue actually does get resolved. And then you can also go and do an occupied, seeing people's behavior during the occupied time frame, see how the general climate is of the area. You know, sometimes you'll be walking through and you'll see somebody is wearing a sweatshirt because it's super cold there. And then that might give you a hint that you're overcooling in an area, right? Or that, you know, everybody has a different needs when it comes to comfort. And maybe that's all you can do kind of to help at that time is to be there and let them kind of express their frustration over it. But talking to the occupants really gives you a better idea of if the system is actually working the way it's supposed to, or if there's an opportunity to save some energy. Then you want to communicate the occupants' feedback to the maintenance people. So those are kind of our audits, and then we also do, like I said, our continuous commissioning. And we go through the buildings and we make sure that they're working the way they were designed. Audits are really used for finding opportunities. These are kind of looked to make sure that you're running it the way it was supposed to be run from the beginning. Now, every building during its lifetime might change, right? A lot of professors or people in the buildings, they might have a need where you've added an extra layer of HVAC to the building. All of a sudden, that the way that that building was designed isn't really isn't how it's supposed to be run today, right? Because you need to do it differently to meet other needs. So you have to figure out what that baseline is yourself and make sure that it's also going back to your performance baselines and the comfort in the building and working with the people to make sure that everybody's doing okay. For us, we have building utility management panels. So we've actually, in our district energy system, we put little notes on these bump system panels to tell us what our seasonal data measures are. So if we see that the KWH at 3 o'clock is above our baseline, then we might look more into it and say what's happening. Or same with chill water, same with steam. And we have little note cards on these bump panels that gives us the time frame that they should be using this amount of energy and the season. And then we're going to examine, again, comfort problems and failures and what's really making the system inefficient. And then we'll identify the changes, and then we'll relay that communication to the right people. And, you know, like I said, this is a very monotonous program where you're always going back through and doing kind of the same things, and it's focused around dedication to energy conservation and communication. So if I sound like I'm kind of being redundant, it's because it's a very redundant process in general, but we've seen great results come out of it. And then, like I said, you're going to track and verify that energy usage. After every month, you'll say, you know what, we just put this opportunity into play at the business center. How is it doing this year or this next month? So you want to see if what you actually are doing is helping the overall program. And you're going to repeat the process. So just to give you guys an idea, this is just zero cost energy conservation opportunities. Like we talked about, schedules, turning off lights, computers, reduce your hot water temp in the summer or raise your chill water temp in the winter. Making sure economizers, if you're in the West Coast and you're in a dry climate, economizers is great, bringing in that fresh outside air to do your cooling. So you don't have to run your chillers or your rooftop units. Use natural light, obviously, when possible. And here's some of the low-cost ones that we focus on. Upgrading or programming thermostats, fixing broken valves, sensors. We've done reducing lamp projects in some buildings where we had too many lumens. So we were able to take out a third of the hallway lighting to make sure that you still had enough lumens, but we were now reducing the energy by a third in the hallways. You can use rebate programs, and then I think calibrating sensors is one of the most important things, is that when you're looking online and you're seeing that that sensor doesn't look right and it's calling for, you know, a hotter discharge there than what you're supposed to be doing in the middle of the summer, then fixing these sensors are really, and finding them are really going to help you figure out, you know, if this building isn't running efficiently or not. Mixed air sensors, return air sensors, discharge air, economizing. So all that is really important when you're talking about calibration. And like I said, the last part of our process is that constant communication with the building occupants. Regular meetings to go over schedules, making sure that they're looking at the data and seeing what's going on. You want to make sure your egos are not getting in the way of any productivity. Like I said, we're not here to turn off the lights when people are working. You're going to then communicate with the maintenance people, give them feedback, comfort feedback too, and communicate any issues you see with them. We're, like I said, kind of the middle of all the silos, right? Bringing that dedicated focus so that the maintenance people can just focus on fixing issues, and the engineers can just focus on upgrading equipment. And we're here to kind of take some of that off their shoulders and make sure that what they are doing is actually making a difference. And then we use a facility fact software that's helped us kind of be our building notebook, so that we understand what is our silos and how are they being integrated into our program. So our success, like I said, we're at our 10th year, in the middle of it, and we're at about 22% of avoided use avoidance. So we're doing great. And that's since 2008. And that's over 52 million of cost avoidance since our program started. Now, like I said, we're a small part of this big energy conservation program. Everybody in the UNM community is contributing enormously to this, especially the physical plant department. They have the highest impact, but we're the ones who are bringing dedicated focus and are the storytellers of this, because if you're not looking at the data and you're not seeing how everything is working, then you're not really telling a story, right? You're not letting the data speak for itself. And so that's where we come in, is we're the storytellers, and since we've started becoming the storytellers, there's been great success in our energy conservation program. So, and then we range anywhere from 16 to 26% in the 9-year program. And in our 10th year, we're projected to be a little ahead of where we were in performance year 9. So I think the biggest thing also is that, you see this curve slowly going up every year, right? If you have dramatic cost avoidance or usage avoidance go up, then there might be something wrong with the data. If it's going down, then maybe you're not doing some of the low-hanging fruit stuff anymore. But as our physical plant department adds more high-efficient equipment and to the campus, it gives us more opportunities to find some of these scheduling opportunities or lighting opportunities. And if we do 1 to 2 big projects a year, your scale should really only be moving up a little bit every year. Like I said, you shouldn't have any dramatic increases or decreases in energy. So this is kind of where we are, and we're just going to be a little bit ahead of where we were in performance year 9 for 10. So that is the end of my presentation.
Well, Matthew, thank you. That was excellent. I think there's definitely some takeaways we can all learn from this. Some of the themes that at least stood out for me are, number one, you got a baseline where you're at today. So track what you have, what you're managing. That's an important first step. Another one then is to create a plan and stick to the plan and get it ingrained in everyone and carry out the plan. Another is, there's some low-hanging fruit, some things that you can do, some free, no-cost options to start on immediately. You outlined some of those. There's also some low-cost things that you can be doing just to get some quick hits, hopefully incur some savings immediately. And then kind of finally, benchmark where you are, start tracking savings or avoided use and cost, and get buy-in, from more team members to continue to expand out the program. So a lot of very valuable things that you covered, and we appreciate that. Before we get to some questions, for all of you that attended that are still on, hopefully that was very worthwhile. I think it was excellent myself. And Matthew went over, he presented about donuts. Hopefully some of you caught that. Well, now that you've attended, you will be receiving a coupon for some free coffee from Starbucks. So that's our gift for attending. And maybe you can buy some donuts to keep on theme for today's presentation. We're going to move forward with some questions. So let's go ahead and start. All these questions were sent ahead of time. So some of you that are still on might have asked these. So Matthew, for faculty, staff, or students, how did you motivate each group?
Well, each group is a little bit different. For students in the residential life, we've been part of new student orientation. I think the students really are about the environment, right? And they want to help reduce the carbon footprint and avoid global warming. And so they're very much willing to help if they know that there's something out there. So the people in the residential halls or the students, we have a energy conservation specialist who works with them specifically. And he's done orientations, he's done presentations, he's worked with the RAs to really make everybody there kind of aware. We've done competitions in the past with each dorm really trying to get them motivated. So you just kind of have to really make them aware and make it so they know how easy it is to kind of help you out with your program. You know, staff and faculty are a little bit different. They have offices, and so you have to really give them the feedback and also make them aware that these things are easy, right? These little initiatives of you turning off lights, computers, and helping us out, it's really simple and it doesn't take much of your time. We're just saying if you're not using it, just make sure that you do turn off that light or you do shut down your computer and you don't open that window so all the air goes out and pumps some more conditioned air into the area. So you just it's about being there like weekly and them seeing that you're, like I said, you're not going away and you're just gonna help. They're gonna help you kind of get that low hanging fruit pointed in the right direction in terms of just the little basic stuff. But the faculty and staff are really they want to help and they want to do what they can in general. Now, we also have policies that the university has implemented about being energy savers as well as consumers and looking to help us out. And in some cases, they are implemented also in their performance reviews, so that if we can kind of show at least the building managers that, you know, your building has reduced energy by 17% or whatever it is, and that's a good reflection of what you're doing and what everybody's doing collectively. So you just really have to find, again, what the person does. Is he more interested? Are they more interested in the financial side, the environmental side, and what is their role at the university and how they can help? So that's kind of how you have to figure out how to motivate each different group.
Yeah, appreciate that. I like how you tie that into results of a job function and performance. That I think that's how you can get some actionable results from staff members. So next question has to do even on topic of keeping staff, and if you have turnover, how do you maintain energy conservation knowledge from year to year?
Well, I mean, Energy Cap has really helped, at least on the data side, of maintaining that knowledge of what's happening in the building from a consumption standpoint. And then while you're doing your audits and while you're doing your commissioning, you know, you learn who is in the building and the new people are coming on and who's your kind of your champions, right? And so by really getting a personal relationship with the building occupancy, you learn how to kind of maintain this and actually do better, a little bit better every single year. So in some cases, we've been working with the same people for, you know, 9-10 years, and then, or 10 years, I guess, in May. And then when new people come in, you know, you have to kind of reintroduce the program and set up meetings and say, this is what the previous person was doing with us, and this is the results that we got from it. And it's always about the feedback and showing them how what them doing these little things and meeting with you is actually turning into a larger amount of success, not just in what they're trying to do, but in what the whole mission of our program is. So I think just knowing the people, and then you know, when you're going through the buildings, you also know the systems very well, and if something changes, you're right there to figure out what happened or learn the new system. You know, when you put lighting in, new LEDs in, you know, you see it, you know it, so you can keep track of it. So it's just it's a constant monitoring of people and working with them to maintain this knowledge, I guess.
Yeah, certainly appreciate that. So you had said earlier that the university reported 22% usage avoidance. So can you talk about how did you verify the cost avoidance, so the cost associated with avoiding all the usage?
Well, in our same baseline year, May 2000, May 2002, May of 2008, you have different rates, and you have different factors that are going into every single year. So that baseline year, you have to adjust, and we talked about a little bit the baseline adjusted to current conditions. You have to adjust the rate, you have to adjust the weather a little bit, square footage, and the billing dates to make sure they're as close to what you're doing this year as they were back then. So you can kind of compare apples to apples. So then you take the cost of this year, and after you change the baseline adjusted to current conditions, take the actual, and then you compare it back to the baseline adjusted to current conditions, and you come up with a number. And so that's kind of how we're calculating our cost avoidance. At the University of New Mexico, we do have most of the buildings being part of our district energy system, but we don't have all of them. So you really have to, in some cases, especially if you have a new building, you have to create a different baseline. But in the end, and the best part about the Energy Cap software is all you have to do is set that baseline and then press a button, and then you can get your cost avoidance. But you always have to make sure that your numbers that you're putting in there are good, and that the rates are correct for the usage, and that you're always constantly reviewing that process too. So again, that's kind of part of our measurement and verification monthly pattern as we look at all of that.
Yeah. And I think another important piece there that Matthew had said was the reviewing of the data. Because there are adjustments that need to be made, and special saving situations you need to take into consideration for potentially each meter in each building. So it is important to review things. And as Matthew mentioned, they have monthly reports that they review, and they look at then what's going on, if there's any data elements that seem to be out of line in each building, and go from there. So it's not just plug in the numbers and off you go. It's a constant upkeep of what's going on in the review of the data. How do you measure persistence? What measures seem to persist and which don't, and why?
Well, for us, I meet with my group on a monthly basis, and from our conversations, I can tell whether, they're meeting their goals and continuing to be persistent and searching for opportunities and searching for knowledge of the buildings. And so that was kind of always something that we just let our people go out and look for opportunities. But you really have to get the knowledge from your team to justify whether they're meeting the goals of which you set for them, right? And so for us, like I said, if we're sitting in a meeting and they don't know what's happening in one of their buildings for 3 or 4 months in a row, but I see the usage going up, that might be an indicator that they're not going through and being persistent enough for. So that's kind of how we measure that, is by our monthly reviews of the data, and knowledge is pretty much proving whether they're being persistent or not.
Yeah. So 3 more questions here, and then we'll wrap things up. What sort of continuing program is necessary to maintain improved occupant habits at an optimum level?
Well, I mean, it's a rinse, lather, repeat. It's waking up and making the donuts, and making sure that everybody knows that you're not going anywhere, kind of thing. Because I think every year our program has become a little bit more successful because we've had more buy-in from everybody, right? we probably started with a lot of people not believing in, well, you're just going to turn off lights and you're just going to do this and doing schedules. That won't lead to energy conservation. But as we've continually been here and shown feedback, the program has, like you've seen in our chart, has gotten a little bit more successful every year. And now we have people who are calling us to check on issues, or scheduling and sending us stuff and letting us know if there are, activities, or if there's a change in the schedules for classes, so that everybody is really contributing to this one big effort. So, as long as we always have the right communication and the right feedback tools, we're going to maintain and get a little bit better than the previous year if we're doing what we're supposed to be doing. If we're continually getting that low-hanging fruit while everybody else is focusing on the bigger picture. So it's just the we're not going anywhere mentality, and everybody's buying in again a little bit more every year.
Yeah, it seems you would need that, because after so many years, things are running efficiently, and that's it. So to continue to drive savings, you really need to get buy-in from everyone in each building and each department to continue to help. So I understand that completely. Did you hire a company to help you achieve your energy savings, or were most of your programs engineered by your in-house staff?
So Energy Education at the time, they're now called Synergistic. They helped jumpstart the program for the first few years. We hired, I think it's a little different now. We ended up hiring at the time through Lobo Energy, the energy conservation specialist, where I think Synergistic now, they're part of their team, even though they work in the same type of role and function. But the good thing about Synergistic is or Energy Education, Synergistic, they had done this before. And so they had this, program and a history of successes for a long time. So, and this was purely behavior based, right? Now, I think we were the second university that they actually came on board and helped, Oklahoma State being the first one. But they got us really jump started and showed us what the process was. And I think we've been able to take it and make it our own with those, fundamentals that they kind of brought to the team. And so, yeah, they did help us in the first 4 years. Yeah.
Yeah, we've had a long-standing partnership with Synergistic and seen kind of the value of them helping organizations like your campus to implement programs like this, and the real value of it. But it's important for each campus or a school district or municipality, whatever it is, to really own the process and make it theirs, to make it work within their framework, which, based on your presentation, you really have on your campus. And so that's really where the success, the long-term success is. So,
and they
last question. Go ahead. Yep.
And I was going to say, they definitely help jumpstart our behavior program. We've been doing, energy conservation at the university for years with the upgrades and lighting projects and stuff. But they helped us bring, I guess, the dedicated focus that we use today. So.
Yeah, and that kind of transitions us to the last question, to compare savings from pure behavior modification, so occupants changing their behavior and habits, to savings from schedule and set point changes, to savings from repairs or minor building system improvements.
Well, you're never going to be able to identify every single measure that is helping you reduce energy. I think we're lucky enough that the University of New Mexico to have a utility department that has provided us with meters on main campus for most of the buildings, where I don't know if I see that in a lot of university or organization campus-wide kind of utility way. So there's no way to just say, well, that person turned off a light and that's why you did a 10% reduction over here compared to the engineers who put in a VFD on a motor and all of a sudden the energy dropped. This is really a collective program from the engineer to the people in the buildings to the maintenance people, and everybody has to work together to get the most out of it. But you're never going to be able to just say this is just because of one or the other. Now, I will say, when you do put a VFD in or you do some big equipment upgrades, that you will see the most dramatic reductions, right? And that's a physical plant department. But in general, when it comes to the total savings or the total reduction, you can't really identify each measure as one or the other.
Yeah, certainly. And I really want to thank you, Matthew, for your time spent on this webinar, for sharing to all of us out there the secret sauce that the University of New Mexico is using to drive really millions of dollars worth of avoided savings, and just all the efforts that you've implemented on the campus. To all of you that are watching this webinar and have participated, we thank you for participating. We appreciate everyone for being good stewards of the environment and natural resources and doing what you can to conserve and to protect our valuable resources. Thanks for your time today, and to energy savings. Thanks.
Thanks.